This lecture, we're going to talk about mixtures and alligation. Mixtures are a collection of variety of entities. That's a mixture for you. Now, we encounter mixtures everywhere in our life. For example, the water that we drink consists of a lot of different types of salts. The food that we eat consists of carbohydrates, fats, minerals, vitamins, proteins, fiber, etc. The metals that we use, they're normally not 100% pure. We have used a lot of alloys in our life, like steel. Steel is an alloy of iron and just some parts of carbon. So basically, all of this is a collection of, all of these are collections of entities, okay, various entities. This is why they're called mixtures. In competitive examinations, we will be seeing questions that test us on the application of the allocation rule in mixtures. Now, what does the allocation rule mean? It means when we have two or more entities in a mixture, okay, and one of them has a higher strength, let's say strength or higher cost or something. So let's call that X. X has higher cost or strength, and let's say there are other entities like Y which have lower cost or strength as compared to X. In that case, when we want to know the quantity of X in the mixture divided by quantity of Y in the mixture, okay? No, it's reversed. When we want to know the quantity of Y in the mixture divided by the quantity of X in the mixture, Y is the cheaper one, okay? Cheaper or lower strength one. X is the dearer one, one with higher strength. Then this is equal to the cost price or the strength of the dearer one, which is X, cost price or strength, minus the cost price or strength of the mean divided by the cost price or strength of the mean minus cost price or strength of the cheaper one. Okay, this is the whole formula. This is the allocation rule, which says that when you want to know the quantities of the different ingredients in the mixture, you use the mean to find the different quantities out. This is the rule. Let's apply this in a question so that we understand everything. Suppose you have mixed 10 kgs of rice, quality A, with 15 kgs of rice, quality B. The price for this is, let's say, 80 per kg. The price for this is, let's say, 75 per kg. Now we want to know what will be the price of the mixture. So how do we do that? See, we have mixed 10 kgs and 5 kgs or 15 kgs of rice. So we'll put that in the formula here. We know which is the cheaper one. The cheaper one is 15. Okay. So 15 upon 10 is equal to the dearer one. Cost price here is 80 minus mean, the cost price for the mean, divided by mean minus 75. This implies 15 times Thus, we exchange the two, we get 25m is equal to, or the mean, the cost price for the mean becomes 1925 divided by 25, which is equal to, this is our answer. Now we use the formula to calculate it. There is an easier way, a shorthand trick, which we'll be discussing in the tips and tricks section. Please go through that one. It's a decent trick to solve questions faster. Now there's another formula that we need to talk about. Suppose you have a fixed quantity of a particular liquid or anything, okay? And now you keep taking some part of that liquid or a substance out and you keep adding something else of the same quantity back to that vessel. So if I ask you after one or two such activities or actions, what is the actual quantity of the liquid left in the vessel? So for that we'll have to use the formula. Here X is equal to initial quantity of the substance and Y is equal to the amount that is taken out of the substance in every subsequent action, and P is the number of times the action is performed. So let's take an example here. Suppose you have 5 liters of milk. And we remove 2 liters of milk every time, and we put 2 liters of water in the mixture. What we do is we have 5 liters of milk, we remove 2 liters of milk from that, and we put in 2 liters of water in the with the milk. So now you have a mixture. Now if you do that action once, it is easier for us to understand, okay? We'll say that 2 liters of milk has been removed, which means now we have 3 liters remaining in the vessel. Now you have added 2 liters of water in the vessel. So we know what is the composition. That is 3 liters of milk and 2 liters of water. But if I do the whole process again, now in this mixture, I remove 2 liters of the mixture and I add 2 liters of water in it. Now the calculation changes, because what happens is, suppose 3 liters of milk in the mixture, 2 liters of water in the mixture. So ideally, if we remove 1 liter, or let's say 500 milliliter of the mixture, then 300 should be milk, 200 should be water. 3 parts of it should be milk, 2 parts of it should be water. So if we remove 2 liters of the mixture, then out of that 3 parts would be milk and 2 parts would be water. So if you calculate it that way, then after the second action, we would have removed 1.2 liters milk and 0.8 liters water. See, now it gets complicated. There is this formula that we've just discussed. If we apply that, let's see what happens. We just want to know x minus y. X is the initial quantity of milk. The initial quantity of milk is 5. The quantity of milk that is removed with every action is 2 divided by 5 to the whole power here is p. We have done it 2 times, so let's say this is the answer. This is equal to final quantity of milk left in the vessel divided by initial quantity of milk. So let's say final quantity upon initial is equal to 3 by 5 square 9 by 25. Okay, that is the final upon initial. We know that the initial quantity is 5 liters, so this becomes final is equal to 9 by 25 into 5, which is equal to 9 by 5 or 1.8 liters. So 1.8 liters remain in the vessel. If you do it manually, like we did, just to explain you how it is done, it's going to get complicated and tough for you. Use the formula, it's easier. Okay, do the practice questions. Best of luck.